One of the great features of the XGB PLC family is the ability to use remote I/O. The XEL-BSSRT remote I/O module is capable of Ethernet IP implicit and explicit connection and Modbus TCP communication with controllers or devices on its network. It is flexible and works with many different manufacturers' controllers. Today we are going to spend a little time getting to know the BSSRT and setting it up for use as a remote I/O platform. This initial setup process will work for either Modbus TCP or Ethernet IP. The differences between the protocols lay in how the data is accessed by the Modbus master, or Ethernet IP scanner or client. First, let's take a look at the LS modules that are able to be used with the BSSRT. The communication and EtherCAT motion modules are not supported. However, the platform does support a vast array of discrete, analog, temperature, and load cell input and output modules, as well as multi-channel high-speed counter modules for encoders and speed detection systems. In our example, we are going to have an XBF HD02A high-speed counter module, an XBE DC32A discrete input module, an XBE TN32A discrete output module, an XBF AD04A analog input module, and an XBF LD02S load cell input module. For our initial configuration of the BSSRT, we will use the XG5000 programming software. In XG5000, we could create a new project for this XEL-BSSRT, however the module ships from the factory with a pre-configured blank project installed. And it is much easier to get all the settings correct if we simply connect to the module and read the project from it. To connect with the module, we can either use USB or Ethernet. This function works exactly the same for the XEM CPU, and we cover that in another video. Please refer to it for further details. We are going to use USB for our connection, as it is quicker than trying to move our computer to the same subnet as the controller to connect. We will use the Open from PLC option. Select USB under the type field, and then click OK. We get a module type mismatch error because we have our 5 modules physically connected to the BSSRT, but the default program from the factory contains no modules in it. We will close this warning for now. Our first step will be to rectify that. We add I/O to the BSSRT exactly the same as the XEM CPU as well, so please refer to that video for further details. If we aren't in test mode, we will need to enter it now, and we will use the I/O sync function by going to Online, System Diagnostics, I/O Information. This opens the I/O Information pop-up window, and we can select I/O Sync. It will give us a warning saying that we are overwriting the existing module information, and this can cause information to be erased. Since we are bringing the empty project into sync with our actual hardware, we are okay with this, and we'll select Yes. If you are doing this with an existing setup, use caution, as you may unintentionally delete variables or I/O information if you do this step to the wrong BSSRT module. The software then gives us a confirmation message telling us that the synchronization is complete. We can select OK to close that pop-up window. Now let's go to the project window on the left side of the screen and double-click I/O Parameter. This opens the I/O Parameter tab, and we can see that our I/O synchronization has automatically added the 5 modules we have connected to the BSSRT. We also see that we can have a total of 8 modules connected if necessary. We have yet to apply this information to the project, however, so we will select Apply. The software then gives us another warning message telling us that changing this information in the project can lead to a loss of comments. We don't care about this for a new project, so we will again click Yes. It then shows us the modules that need to have variables created for them. By default, none of the boxes are checked on the left side of the screen, and we want to register variables for all of our modules, so we will check them and click OK. Now that our I/O is synchronized, we are ready to look at communication configuration for the BSSRT. We can access this by going to the project window on the left side of the screen and selecting Basic Parameter. This opens the Basic Parameter settings screen. On the Basic Operations Setting tab, we can name our module, change the input filter for our non-high-speed digital inputs if desired, and select or deselect a few device settings. We don't want the outputs to stay frozen when we lose connection, we want them to go off. We also don't want the data words swapped, but we do want the inputs to stay frozen in their last state. So we will stick with the default setup of number 1 and number 2 unchecked, and number 3 checked. On the Communication Basic Settings tab, we can set up our IP address settings. The BSSRT supports static, DHCP, and boot P IP information assignment. We will use static and set our IP address to be 192.168.27.120 and our gateway as 192.168.27.1. These IP address settings are selected based on the network that I am using. Your network settings will likely vary from this, so you may need to check with an IT professional to see what IP addressing you should use. We will leave the other settings alone as they are good for our application. The driver settings section is only used with RAPINet Plus protocol, which we won't be using so we can ignore it. The final tab is the host table settings. This also works like the host table settings in the XEM CPU, so please refer to that video for further details as well. Since we aren't worried about unauthorized IP address access, we will leave the table disabled so any IP address can access the data. Once we select OK, we can save the project, and then write the project to the BSSRT module. We are now ready to access the remote I/O information from our controller. Perfect.